So there are a number of ways you can approach this problem. You can use trial and error, which can be good in situations where the numbers are quite simple, there isn't very many elements in your sets, and the answer can be arrived at quite quickly. But sometimes it may take quite a long time using trial and error to actually arrive at your answer. So in this case, we have 17 students that like tennis. We have 11 students that like basketball, and then there is some unknown, which is the ones that like both, that like tennis and basketball, and they all equal 25. So we can use trial and error to try and work out what the unknown is. So if we reduced each side by 1, so if we reduce the tennis and we reduce the basketball by 1, we could then see if this equaled 25. Well, we can see that 16 add 10 is 26, add 1 is 27. So that's not correct. We know that that's not the right answer. So if we reduce both by another 1 and increase the unknown by 1, so does 15 add 9? Well, that equals 24. Add 2, that equals 26. So we know that that's not the right answer either. So if we reduce them by another 1, and that becomes 14, add 8, add 3. So if we add that all up, yep, that does become 25. So we know that our unknown is 3. And that is using the trial and error method. But there is a much better sort of mathematical way that we can solve this problem using algebra, and that might sound scary, but it actually makes it a lot easier to see what's going on and what we actually need to do. So if we think of our Venn diagram here, so we have the tennis set and we have the basketball set, and then the two who don't play either. So our unknown, we could use a question mark, or we could just use an X to represent our unknown. It's the same as using a question mark. So we know that the number of people who like tennis is 17, but some of those also play basketball. So to work out the ones that only play tennis, we need to take away the ones that also play basketball. And it is the same with the basketball. We know that there are 11 students who play basketball. So we need to take away from the students who play basketball those who also play tennis. So this now becomes 17 minus x, because that would leave only the students who play tennis. And this becomes 11 minus x, which would leave the students who only play basketball. And that is no different to putting the question mark in there, taking away the ones that are in the intersection, the ones that are in the middle. So putting this all together, we know that if we add this and this and this, we get 25. So if we have 17 minus x, add 11 minus x, that all equals 25. Now we can simplify this and another minus x, and we have a 17 and then an 11. So that becomes 28 minus x equals 25. Now that is now quite easy to see what the x is. It's quite a simple, nice little equation there. 28 take away something equals 25. Well, it can only be 3 because 28 take away 3 equals 25. So we know that our x is 3. And that is a much easier way of doing it when the numbers become more complicated and you might have more data in your sets that you need to work out the answer to. So by using algebra, we can make it a lot simpler and a lot easier to answer the question. Now there is a third way that you can also think about this. We know that there are 17 students who play tennis and there are 11 who play basketball. Now in there are students who play both. If we add them together, we get 28. But we know that there are only 25 students left to place in our Venn diagram. So 28 minus 25 equals 3. So we know that 3 of these people have been counted twice. They've been counted in this set here and they've been counted in this set here because we're 3 over, 3 more than the 25 that we actually needed. So these 3 students have been counted twice. So we can just take them off our number. So we know that in the middle is therefore 3. In the intersection, there are 3 students because we are 3 more when we add up the 2 sets than 25. So that is quite a quick way as well of finding out how many go in the intersection.